Okay, good morning class. So today we're looking at, I think there's a second video for the November 2020 paper, and we're still busy with paper 1. Is that correct? Yes. Okay, and this is the first of the exams that we're going through at the moment. Okay, so the first question, okay, we stopped at 4.3, no? There's a question we must still answer, correct? Right. So we are told that a quadratic sequence is determined by the formula. Tn is equal to negative half n squared plus 9n plus 16. Calculate the value of the largest term in the sequence. So the largest term is also, what to us? The maximum. Not so. You see what type of, if I had to draw a parabola or a quadratic function for this, will this graph have a maximum or a minimum? Maximum. Hence they're asking you for the maximum value or the largest value. Can you see that? If this was positive, what do you think they would have asked? The minimum value. You guys understand? So it is dependent on the module given or you're working with. And that's how we form the question. Okay? So how are we going to get this turning point? One of two ways. I can either, what can I do? Work out the axis of symmetry by using minus b over 2a, or complete the square. Not so. So what I'm going to do is I'm going to complete the square. So 2n is equal to, I take negative half as a common factor. It's n squared minus 18n. So negative 18 times negative half is positive 9. And negative half times negative 32 is positive 16. You say, okay, we've got negative half n squared minus 18n plus a number to complete the square with, minus that same number, minus 32. So it's going to be 18 times half, which is 9, and 9 squared is 81. So it's going to be negative half into, there's my perfect square trinomial. It's n minus 9 squared minus, it's a 3, 8 plus 3 is 11. Is that correct? Sorry? So multiply negative in, so it's negative half into n minus 9 squared plus 113 over 2. So in other words, this will have a maximum value of 113 over 2, and it occurs at an n value of 9. So we could calculate the value of the largest term. So what's the value? Therefore, T9 as the largest value of 113 over 2. That's one way of doing it. Otherwise, I could have worked out the axis of symmetry, which is minus b over 2a, which is negative 9 over 2 times negative half, which is negative 9. No, positive 9. Normally it's an x value, but here it's going to be an n value. Then what do we do with that? We substitute 9 into this. So we work out T9 equals negative half times 9 squared plus 9 times 9 plus 16 gives you positive 113 over 2. In conclusion, therefore T9 as a maximum value, the maximum value occurred the ninth term, which the corresponding value is 113 over 2. Any confusion, people? Right, any confusion, people? No? Okay. Let's look at question 5. In question 5 we are given P of x equal to negative 2 over x minus 1 minus 5. What type of graph is that? Hyperbola graph. Okay. Draw a neat sketch of the graph clearly indicating the intercepts with the axis and any asymptotes. Okay. So the first thing we draw in is our asymptotes. Not so. What's the equation of the asymptote? Y is equal to negative 5 and x equal to, okay. So how do we work out our x-intercept? We let y equal to 0. So we have 0 is equal to negative 2 over x minus 1 minus 5. They get over, becomes 2 over x minus 1 equals negative 5. Cross multiply. So 2 is equal to negative 5x plus 5. So the negative 5x is equal to negative 3. So x equal to 3 over 5. You all okay with that? I'm going to move this over a bit. Bad idea. So 3 over 5 is fairly close here, not so? As we see, that's negative, so it's going to lie in quadrant 2 and 4. So let's look at the y-intercept. What do we do for y-intercept? We let x equal to 0. So we say P of 0 equals negative 2 over 0 minus 1 minus 5, which is minus 3. You all okay with that? The graph is going to come close, does not touch the asymptote. There we go. Any confusion? No? Next question. We are told that if y is equal to x plus k is a line of symmetry. Now remember, the line of symmetry, one is coming through there and the other one is coming through here. Not so. The one with the positive gradient is y is equal to x plus c, and the negative gradient y is equal to minus x plus c. That's the equation of the axis of symmetry of both. If y is equal to x plus k, so that is this one they're referring to. Can you see that? Is a line of symmetry of P of x. Determine the value of k. So how do I solve for k? There's actually now a k and obviously I substitute the point that the symmetry line is going through, which is 1 and negative 5. We will substitute 1 and negative 5 into P of x. Okay, hi. Yes. So remember this P of x, this is your y. Okay, so what do we have? Negative 5 is equal to, that's x and a y. Negative 5 is equal to negative 2 over 1. Why am I substituting it into P of x? I was going to this equation here. Not so? So why did you tell me? Huh? Oh my word. Is this going to be you guys next year as well? Like? Huh? Why? Huh? Talk to me. Yes. Right, it's x and a y. So negative 5 is equal to 1 plus k. So k is negative 6. So y is equal to x minus 6. So the answer that they were looking for is that k is equal to minus 6. You guys understand? Then the next question says, describe the transformation from P 2k. If k is equal to, if you look at k of x equals x plus 3 over x plus 1. Okay? However, f of x is, sorry, p of x is negative 2 over x minus 1. Negative 2 over x minus 1 minus 5. So what do you notice already? What do you notice between these two? Is the denominator the same? No. The denominator became positive 1. So it's one of two things. I could have either translated it from negative 1 to 1. It had moved 2 units to the left. Okay, you could have said that. The graph is shifting 2 units to the left. Or I could have said the graph is reflected in the y-axis. What happens if the graph is reflected in the y-axis? X becomes negative. So it's no more p of x, is now simply a y is equal to negative 2 over minus x minus 1 minus 1. Okay? But I got negative as a common factor. And divided with that negative, it becomes positive 2 over x plus 1 minus 1. So what do you notice? The denominators are the same already. But to get it in that form there, I must multiply, I must find an LCM. And what's my LCM here? X plus 1. So I multiply that by 1, multiply that by 1 becomes 2, minus 5 into x plus 1, which now becomes negative 5x, negative 5x, that's minus 5 plus 2 is negative 3 over x plus 1. Okay, but there is now a problem there. Okay? What's the problem? Is the negative 5 here. So what I should have done was I first had to get k rather in the form of the standard form of hyperbola. Then I would have seen a better translation there that's taking place. Okay, so let's rather go back. Okay, take it from here. Start with k. You say k of x equals, now you see you got x plus 1 here. Alright? And then I put on top x plus 1. Plus x plus 1. So what must be added to x plus 1 to get x plus 3? 2. Okay. So 2 must be added. You all okay with that? So what is x plus 1 over x plus 1? 1. So the equivalent of k of x in the standard form is going to be 2 over x plus 1 plus 1. Right. Now I must get this equation now in that form. So what do I do first? You still see that there's a change here. So what did we say earlier on? It is reflection in the y-axis. If something is reflected in the y-axis, what happens? X becomes negative. Let's just take this calculator away here. Reflection in the y-axis, x becomes negative. Okay? So that now becomes y is equal to negative 2 over negative x minus 1 minus 5. So without this negative here, it would give us y is equal to 2 over x plus 1 minus 5. Then how do I get from minus 5 to positive 1? Shift the graph 6 units, yes? Units? So what are they looking for? They're looking for this here, shift these sections up, and reflected in the y-axis. That's how you're going to get your 2 marks. Okay. Any comment there? Yes? The idea is to get, okay, let's go again. The equation of P of x is what? Negative 2 over x minus 1? Minus 1. They want to know how do we move from P of x to K of x. If K of x is x plus 3 over x plus 1. But what you should notice is that the representation of K is different to the standard form of your hyperbola. Okay, so we can't see the transformation nicely here. Okay? So what we must do is we must say, okay, let's get it in that form of P of x, or the standard form of your hyperbola. So we got K of x equals. So you ask yourself, okay, how do we get the constant? We get the constant by you see here, that's x and x here. So to get the constant here, it has to be x plus 1 over x, or 2x plus 2, because then I would have left with 2, or 3x plus 3, then I would be left with 3, or so on and so on, to get a constant term. So since there's no number, I just realized now early on when I had that 5 in front, I could have gone with the same idea. But okay, it's gone now. So it's going to be x plus 1 over x plus 1 plus. So what must be, so you see here, that's going to give my constant. So the question is, what must be added to x plus 1 to get x plus 3? 2. Remember in mathematics, I don't change the value of anything. I'm only simplifying. So if I bring this as one term again, then I would be left with x plus 3 over x plus 1. You guys understand? Right. So we say that x plus 1, this can be a constant, that becomes a 1. So it's 2 over x plus 1 plus 1. So the question could also read, describe the transformation from P to K if K is equal to 2 over x plus 1 plus 1. Would have been the same thing. Does it make sense? Right. Now the question is, you see as a negative 1 here, but here's a positive 1. So how do I change the sign on the denominator? I'm going to either translate it as I see 2 units to the left, then I was adding 2 on the x. But then I wouldn't eradicate, or I wouldn't have gotten rid of the negative. Can you see that? So to get rid of the negative, I would have to reflect it in the x-axis, and then I take the horizontal shift into account. So it would have been 3 translations or transformations if I had taken the graph 2 units to the left. So instead I could have just said we reflect it in the y-axis. So what's the rule if something reflected in the y-axis? X becomes negative. So it's negative 2 over negative x minus 1 minus 5. So what do I do now? Right? So if I take out negative as a common factor and divided by that negative, we'll have y is equal to 2 over x plus 1 minus 5. You see now this fraction there, it's exactly the same as this fraction. Did you see that? So the only thing that's bothering us now is this, how do we get from minus 5 to plus 1? The graph must shift 6 units up. So shift, at this point the graph, we can say then shift 6 units. Okay. Alright, let's move on with our lives. 5.2. In question 5.2, you're given Q of x equal to half into x minus 4 squared minus 2 and r is equal to 16. Write down the minimum value of Q. Why do you think they asked you for the minimum value? Graph is positive, smiling. That's why they asked you for the minimum value. So what is the minimum value of Q? Sorry? Negative 2. Do you guys understand? It's negative 2. Remember this coordinate here is going to be 4 and negative 2. It's coming from this, from the equation in the tally point. Can you see that, people? Then the next question says, write down the equation of the axis of symmetry of Q. The axis of symmetry is going to be the line going through like that, not so? And what's the equation of the axis of symmetry? X is equal to x equal to 4. So where's the additive inverse on your x? Next question. In 5.2.3, if 10 and 16 is a point of intersection of P and Q, determine the other point of intersection. Now, there's one or two ways of doing this. Okay, to either work out the points of intersection by setting the two graphs equal to each other and then working out x. Or if you take into account, you have this parabola, you have the axis of symmetry, and I highlighted for you that at 4 already. This coordinate you have told you it's 4 and negative 2. So r is equal to 16 is a line going through like that. R of x equal to 16. So the one point has to be 10 and 16. Why wouldn't it be on this side? If it was on this side, this number had to be less than 4, according to the x. Not so? So what is this distance from there to there? Remember your x value is 4 here. So 4 to 10, now how many units is that? 6. So I go 6 in this direction. What would it be? Negative 2. And? What's the y value? 16. Okay? So this is the answer that you're looking for. Okay? Otherwise, as I indicated, you could have also worked out the points of intersection. Okay? Then we're on to question 6. In question 6, you are told the diagram alongside shows the graphs of f of x equal to a times b to the x and g of x equal to mx plus c, which intersect at 2 and 8, and b, which is negative 3, and q is a point on f of x. Okay, put this behind here. Right. Let's look at the first question. Right, first question. What was the equation of f of x? A times b raised to the x and g of x. Sorry? mx plus c, which is a straight line. Right. First question, determine the value of a and b. Where does a and b belong? A and b belongs to the equation of f of x. It's two unknowns. Can you see that? So there's a chance of going to simultaneous equations probably. Okay. Now, do we have 2 points, 2 known points on the exponential graph? Yes. We have d and we have a. We have b, but we don't have the coordinates of b there. We only have the x coordinate, not the y. Can you see that? So what we do is, we substitute a, which is 2 and 8, into f of x. Remember that's an x and a y here. So 8 is equal to a times b to the 2. I should have actually gone with d first, okay? So that would have eliminated my b value at this point already. So let's call this equation 1 for now. Then of course we're going to substitute d, which is 0 and 2, into f of x. Again, that's an x and a y. So 2 is equal to a times b to the 0. Anything to the power 0 is 1. So a is equal to 2, and that's equation 2. So I got my a value now. So what do I do now? I substitute a wherever I see. I substitute 2 wherever I see a. So 8 is equal to 2 times b squared. I divide by 2 both sides. So b squared is equal to 4. The square root thereof, I must not forget, plus minus. But it's only going to be plus here. Why? B must be positive. B must be greater than 0. Otherwise, you're not going to get an exponential function. Okay? Yes?
Also, can you please say all the time when the plus minus is going to be so?
Did I make a mistake?
No, sir.
Okay, what do you say?
The plus minus, sir.
The plus minus.
Yes, sir.
Why is there a plus minus? You see, if you got x squared minus 9 is equal to 0, the ask you to solve for x, what would you have done? Difference of 2 squares is, which is x plus 3, x minus 3. So x minus 3 is equal to 0, x equal to 3. Or x plus 3 is equal to 0, so x equal to minus 3. Did you see that? Now, if you see it, okay, but we could have taken it over the equal sign. You're absolutely correct. Take the square root. But then you only got 3. But you remember in mathematics, whichever route you follow, you must end up with the same answer. Not so? So, whenever we apply any even root, square root, fourth root, sixth root, we're going to add a plus minus. So, as to pick up the other solution that we have omitted. Make sense, people? But in your exponential graph, we know that b can only be positive. That b will never be negative. Okay? You guys understand? Okay, so I've written it in there. So I'm going to take this off. So the next question says, if a is equal to 2 and b, if a is equal to b is equal to 2, which now confirms my answer, not so. And if you got a different answer, you must use a to be 2 and b to be 2. Okay? You can't now say, no, I think I'm more right than you, and use the answer you have. You must use what is given to us. Okay? So if a is equal to b is equal to 2, calculate the value of q. Now where does q lie? Q is lying on p of x, f of x. Can you see that, people? So what we're going to do is we're going to substitute. This is now 6.2. Substitute b, which is negative 3 and q, into f of x. Okay. Remember the equation of f of x now is 2 times 2 to the x, which is negative 3, equals, remember x and y, it's your q. So Q is going to be a quarter. Let's check if that's correct. So B is going to be negative 3 and a quarter now. Any confusion there? No? Determine M and C. Where does M and C belong? Equation of the straight line. How do I work out the equation of the straight line? I must first work out my gradient, which is y2 minus y1 over x2 minus x1. Now, do we have 2 points as lying on the straight line?
Yes.
We have A and
C.
C. Okay, so we're going to change in y, we're changing x. So if this is x1, that must be y1, x2, y2, and so on. Okay, so I'm just making 8 y2, so it's 8 minus 0 over 2 minus 2, which becomes 8 over 4, which is 2. So my m value is 2. Not so? And what is my corresponding y value? We've got now y is equal to 2x plus c. I substitute one of the 2 points that's lying on this graph, which in this case is A. 2 and 8. It's an x and a 1. So 8 is equal to 2 times 2 plus c. What's 2 times 2? 4. 8 minus 4? 4. Doesn't make sense, people. Yes, 2 and 4. Yes, it doesn't make sense. So this is my c value. So y is equal to 2x plus 4. Any confusion here? You with me? 6.4. .4. 6.4, the question is to write down the range of f. People, what's the range of a graph? All possible y values. The range is all possible y values. So if you're looking at f, does this graph exist at negative infinity on your y? No. Where does this graph start existing at? 0 onwards. Not so? From 0 onwards this graph is existing. Can you see? So what is my range? Y is greater than? Am I going to say greater and equal to? Why not? Is that asymptote? Not so? You never put an equal sign in an asymptote. Okay? Well, 6.5. Write down the equation of h of x. Now this is now a different equation. Is the reflection of f of x in the x-axis. So what's the rule if something reflected in x-axis? Y becomes negative. Okay? So that now it becomes negative y equals, it's f, so it's 2 times 2 to the x. So I divide that by negative, so y is equal to negative 2 times 2 to the x. And this is now the equation of h of x. You guys understand? Followed by shifting 3 units up, sorry. So it must be plus. Okay, don't want to be in trouble, so I'm trying to get done here now. Right. 6.6. 6.6. Use your graph or otherwise to determine the values of x for which f of x plus 5 is less than g of 4.5. So what we do is we take it over the equal sign, so it becomes f of x must be less than. Now g of 4.5 is the g of 4.5. If I say x, I put the 4.5. So it's 2 times 4.5 plus 4. That is g of 4.5. Not so? Minus 5. So put this in a calculator, what do we get? It's going to be 9 minus 1 is 8. Can you see that? So where's f of x? Remember this is a y value of 8, no? There's your 8. Can you see that? So which values of x is f of x less than 8? So for which values of x is that the case? For x is less than 2. Right? Any confusion? People enjoy the rest of your day. We'll carry on with the rest of this paper in the next lesson. Good afternoon, class.